Hey and welcome again, I'm glad to see you in the course. Before we get started, here is a bit more information about what we will do in the course. I will show you the different steps of the project with the concepts you will learn. I will also clarify what to expect and what not to expect. And finally, I will give you some tips on how to follow the course so you can get the most out of it. And first, to be clear, this course is about creating the stepping stone for any robotics project, which includes writing a URDF for a robot, simulating the robot in Gazebo, controlling the robot with Gazebo plugins, and packaging the application correctly so you can build a user application on top of it. I will not cover ROS2 control, nor the navigation stack and MoveIt. Those are outside of the scope of the course, and each one can probably fit into an entire course on its own. But what you will learn here is required so that you can make those frameworks work afterwards. And it will be a really great step for anything else you do with ROS2. So now let's get an overview of each step you will take in the course. First, in section 2, you will discover what TF is and why it is important. We will visualize TF in the tool called RViz. TF or transform is the base layer of any robotics application, so that's why I'm focusing on this first. After this quick overview in section 3, we will start the course project from scratch. Here we will focus on writing a URDF for a robot so that you can describe the different parts of the robot and how they move relative to each other. We will start here with a mobile robot. You will see how to write links and joins, and I will share with you a process that will help you gain a lot of time when doing that. Then in section 4, you will see how to create what's called a robot description package with a launch file to start the robot state publisher node and publish the TF using the URDF that you have just created before. We will do the launch file in Python, but also in XML, which is going to be much easier, and later on in the course, I will continue with the XML launch file. In section 5, we will improve the URDF with a tool called Zacro. This will make your URDF cleaner and more dynamic, and it's also going to be a good preparation for the next step, which is in section 6 to adapt the robot for a Gazebo simulation. Here you will add collision and inertia tags in the URDF so that you can spawn the robot in Gazebo. At this point, you will have a simulation of a robot with real physical properties. You will discover what is a Gazebo plugin so that you can simulate the hardware of the robot and thus control the robot. We will also add some objects and walls so that you can spawn the robot in a complete simulated world. And finally, we will create another ROS2 package with another launch file so that you can start the application with just one command line. Then in section 7, you will see how to add and simulate a sensor on Gazebo, and here as an example, I will use a camera sensor. I will give you a process that you can use to find information and simulate any other sensor. And after this, the project is done, but in section 8, I will give you another project so you can practice even more. In this new project, we will do again all the previous steps, but this time to design and simulate a small robotic arm. At the end, you will even combine the two robots so that you can have one mobile robot with a robotic arm on top. So as you can see, that's a lot of things we will cover here with many steps. Now, what I recommend so that you get the most out of the course is to, well, first, make sure you have some ROS2 basics. It will actually be much faster to finish the course if you have already a good understanding of ROS2. Then follow the course in the order, as each video is one step based on the previous steps. But at any time during the course, feel free to come back to previous lessons if you didn't fully understand the concept. Also, as the course is project-based, I encourage you to do the project at the same time as me. Writing the code and doing the experiments will make your progress much faster than if you were just watching the videos. There are a few extra activities during the course and an extra project at the end. Make sure you take enough time to try to do them on your own before you watch the solution. And finally, stay curious, have fun, and don't hesitate to challenge yourself and practice on your own to go further. Alright, and with this, let's start the course.